I need to calm down. I just went into grumpy mode because technology broke and because kids are late and unprepared. Happy joy, Mr. Dueck. Look along with me. Which of the following scatter plots would best fit with a logarithmic equation? Let's see. Sorry, which one looks like a log graph? If you had to guess. Okay, this is a logarithmic equation. What type of equation is equation 2? Okay, this is linear. And we could say decreasing. What type of equation is equation 3? Is scatter plot 3? Okay, this is exponential. It could be half of a parabola, I'm not sure, but it looks like it's getting really steep really fast, so my guess is exponential. I'd really need more data to be sure. So I think this is exponential and it's increasing. What about the fourth one? Linear increasing. A scatter plot is sort of like, I'm going to date myself a bit here, like an old baseball card or trading card or hockey card, where if you see the picture, you know a lot about the player stats, domain, if you see the graph, if you recognize what type it is, you should be able to then say, oh, I know kind of how it behaves. I know the domain, I know the range, I know intercepts and things like that. And what we're really trying to do last unit, Rachel, this unit, and one more unit, is we want to build up your arsenal of players that you're familiar with, of graphs that you're familiar with, so that you can recognize them when they appear and say, oh, and I know how they behave. So I'm big on teaching physics and finding applications. So here is one. The flash, it turns out, on most digital cameras, not on the phones, but on the old cameras where the flash had to slowly charge up. Remember when you sometimes had to you'd hear it kind of whining, very, very high-pitched, and then it would charge up, and then it would flash? Requires a charged capacitor in order to operate. They've since redone the circuit a little bit. The percent charge, Q, remaining on a capacitor was recorded at different times, T, after the flash had gone off. The T.5 flash duration represents the time until a capacitor has only 50% of its initial charge. I'm reading here. I'm not quite understanding this, but I'm going to read through and see if I can figure it out. Right now, I know that Q stands for a percent, and I know that T stands for time. I got that in seconds. It represents the length of time that the flash is effective to ensure that the object being photographed is properly lit. You know what? I think that sentence there is just filler to try and convince people that this is a legitimate physics application. What I do see is some data. The question is, what do I want to put on the X? What do I want to put on the Y? Right now, I'm going to start out thinking maybe they did this correctly. Let's put that on the X-axis. Let's put that on the Y-axis. Let's get out our graphing calculator, and let's enter this into the stat menu. Delete any ones you have there. Be really careful as you're typing. Let's see. Wow. Come here. 0, 0.01, 0.03, 0.05, 0.07, 0.09. There's my data. It says construct a scatter plot, and since this is the logarithmic unit lesson, I'm kind of hoping it looks like a log graph, maybe. So I'm going to go graph. Hey, that does look sort of like, remember we said one of the log graphs could look like that? It looks like that shape. It's not going through right there, but it does look like that shape at least. So construct a scatter plot. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I think the 6th point is really, really low. Anyways, it looks like 2, 3. Now, you might say, Mr. Dueck, this also kind of looks like a straight line. True, Kyla. It does look like a straight line. In real life, you, again, need several thousand points of data to be more convinced. I just don't feel like entering even, in fact, there's one example from the textbook that had 40 pieces of data. I said, forget that. I'm not going to spend time entering 40 pieces of data. I'm going to tell you what it's supposed to be, and that's bad research. It's bad math, but it's good homework, less time typing, if that's okay, Sean. So part B says determine a logarithmic model. Find an equation. So how am I going to, how do I find an equation? How do I do a regression? What do I do now? Okay, calc. But now, instead of saying it's linear, instead of saying it's a parabola, instead of saying it's a cubic, arrow sideways, instead of saying it's a x to the fourth, ooh, maybe it's a log graph, which is arrow sideways, which is F6, and then F2, and it's saying, okay, here is my suggestion, y equals a plus b, and I think by default mine goes ln. Does yours by default go ln, or does it give you a choice between the natural log and a, okay, that's, you know why? Because in research, that's what's used, by far the most, okay? So we're going to use the ln. Connor, you looking puzzled? Your question? Got it? Okay, we've been doing, this is very similar to what we did with polynomials, with linear. So we started out doing linear regression, we did quadratic regression, cubic regression, we did a couple lessons ago exponential regression. Here's logarithmic regression. So the equation template is y equals a plus b times ln x, y equals a plus b natural log of x. So if I fill in the equation, then it's going to be, what does it say that a is? 0.4596. I don't want to round off too much. I haven't gone over the polynomials test with you guys yet because it's taken me this long to get everybody to write it. But there were some people that were getting this and saying, oh, that's 0.4. You've rounded off way too much because you're going to be using that equation to find other values. You don't want to use error to find more error. I'm going to go to 4 decimal places. I'm going to go 0.4597. 0.4597 plus, and then what number is in front of, negative 0.0998. Negative 0.0998 ln. Oh, but I don't want to use x. What letter is sitting, what letter should I use for my x variable t? And what letter should I use for my y variable? Q. Where Q tells me what percent this capacitor is charged. What a capacitor is, by the way, it's an electric device that you can slowly feed charge into that will hold more and more and more and more and more and more and more charge and then get rid of it all at once. Like a camera flash. So how many of you have a digital camera, not your phone, but a digital camera? Okay. Depending on the quality of the flash, some of them may still have a capacitor flash because it's got a small battery, and that small battery isn't big enough to give you a consistent, nice, bright flash. But what they can do is bleed off charge from that small battery, feeding it into a capacitor, 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 feeding it into a capacitor until the capacitor is full, and then now you have a whole bunch of charge stored, and you can use that as your camera flash. Okay? You've all, certainly 5 or 6 years ago when you saw cameras, they still all had that type of flash. The delay took a little bit of time for the flash to, quote, charge up. Yeah. How much time? About that graph. So there's our equation. C says use our model to determine, okay, so we're going to copy, enter. And now if I go to the graph menu, and don't forget to turn that equation on, I've got that equation stored. And the reason I like using the copy method is it's stored to like 9 decimal places instead of even the 4 that I rounded off to. Because even the 4 that I rounded off to is wrong, technically. So it says use it to determine the t.5 flash duration during the nearest hundredth of a second. So I guess what it's saying is what? The t.5 flash duration is when it has 50% of its initial charge. It's saying Okay? This is phrased kind of confusedly. I won't do that to you on a test. I'll make it clear. What it's saying is find t, find how long it takes for the flash to get up to 50% of its charge. Are you being asked to find an x value or a y value? X value or y value? What's it asking you to find, Colin? Find what? Find what? It's more specific in this question. Find. Okay, t. Is t sitting where the x is, or is t sitting where the y is? So am I being asked to find an x value or a y value? Colin, you say what? You are ever so clever. So I'm going to use the draw. There's my graph. Calculate. Arrow sideways. I want an x calculation when y is 50%. How? Oh. Not found. Why not found, Mr. Dueck? Let me check my view window. Mr. Dueck, you've really butchered this, haven't you? Mr. Dueck, and this is why Colin was so confused. Mr. Dueck, I put the x and the y in the wrong place, didn't I? Roy, is that what you were saying? And this is going to be on the internet for posterity because I don't mind making fun of my own ignorance sometimes. I said this was the y, the x value. Q, Colin, should be right here, shouldn't it? And t should be right there, shouldn't it? And you were saying, Colin, Mr. Dueck, it's asking us when it says find t to find what, Colin, with authority, making fun of me this time? But what should it be, really? The first time you said we're finding a y value, and that's what you said the first time. You were right, and I contradicted you, and I forced you into the wrong answer, and I apologize. Let's try that again, Mr. Dueck. Let's go draw, G-solve. It's actually a y calculation because I put the t and the q in the wrong place in the equation. When we're at 50% charge, how long will that take? 0.069 seconds. Takes about 0.07 seconds to charge up to 50%. Let's see if I can redeem myself a little bit. Let's try another one, because that was terrible. Example 2. Example 2, and then it says example 3 underneath because I stole this from the internet and I couldn't get rid of the example 3. You can cross that out if you want. Okay? A corn plant. Kayvon, question?
No, I got it.
You got it? Okay. Let's try another one that I think is a little clearer. A corn plant will grow rapidly after it first emerges from the soil and then eventually slows its growth rate. Okay. Agronomists record the average height for a particular type of corn as a function of the number of days since it was planted. Here's the data. Okay. Well, let's try letting that be x, let's try letting that be y, and let's see if it looks like a logarithmic graph. Stat, delete all, delete all. So I'm going to move this over a little bit so I can see all the data. There it is. 8, 14, 22. 4, 18. Whoop, 732. That'd be big corn. Got the data entered in. Let's do a quick graph. Yeah, that looks kind of like this type of a log graph. Again, not enough points, but use our imagination. So A says, use your calculator to determine the best fit logarithmic equation. Again, express your answer in that, except x is going to be the days. So call in very carefully. I'm going to put a D here for the x, and y is the height. I'm going to put an H here for the height, and I'm not going to get it wrong this time. I read carefully this time. Let's do a logarithmic regression. So let's go calculation. And it looks like the equation it suggests is negative 74.3833. 74.3833 plus 37.2082 natural log of, not x, Mr. Dueck. What did you say with the x-axis? D for days. There's my equation. It says sketch a graph of your equation below. So now instead of saying the scatter plot, it wants to see the actual graph. So let's copy this equation. Let's go to the graph menu. Turn the equation on. Only they've been very specific. They want me on the x-axis to graph from what to what? 0 to 100. So I'm going to change my view window, which is Shift, Rachel, F3. And I'm going to go from x min of 0 to an x max of what? 100. Scale, I could have 100 hash, going up by ones, I could have 100 little hash marks. What would be a good scale to go up if we're going from 0 to 100? What would be nice numbers to go up by? Let's go up by 10. Okay. Y min and Y max, I'm not sure. I'm going to see if my graph goes off the page. If my graph goes off the page, I'll have to bump up my Y maximum. Let's see what it looks like. Exit, draw. No, I think I'm okay still. So it says sketch the graph. It says label your window. So if I was labeling the window, I went from 0 to 100 on the x-axis. And then I went from, what was my y window? Negative 19 to 96, which is, did your calculator also suggest those same values, or yeah, okay. So it's doing, these newer calculators, the old calculators were stupid. This one actually looks at the graph and picks somewhat intelligent windows, not perfect, because I would never start at negative 19, I would start at negative 20, or negative 25, but okay, and I would never go to 96, what would I go to? I'd go to 100, so, but at least it's giving me a rough one. I'll use this one. So I'll go from negative 19 to 96. That's how you show the window. You do the X window first in square brackets, the Y window next in square brackets, and that way I can reproduce the graph. By the way, it says, let's now answer some stuff. The corn will develop tassels, that's the little furry part of the corn, the little hairy part thingy, when it reaches a height of 4 feet. To the nearest day, use your model to predict when the corn will tassel. What does this question want me to find? An X value or a Y value? It wants me to find something to the nearest what? Day. Here's how else I know. Here's the only number they gave me, the 4. Now they didn't write it, they didn't write a number 4, they typed it out. But what is that for? Is it days or is it height? Okay, so here's what they've done. They've given a Y value of 4. Find an X value except H and D. So let's go to my graph. G solve. Ah, good catch. My units don't match. I'm going to have to say given y equals, how many inches in 1 foot? I pulled this from an American website, sorry. Okay, I'm hoping even though we've been metric, probably because in sports it's still often done in imperial, hopefully you know that y equals, so not 4, 48 inches. Yes? So we're going to do an x calculation when y is, I'm getting 27 days, isn't it? Oh, there's a data. You know what, though? I guess this data here actually, because we're only looking at one corn plant, that in theory, sure, but in theory, somewhere around day 27, you know what you'd probably say? Sometime during the third week, is because plants grow at different rates and soil and temperature. There's all sorts of other factors. So yeah, from here it suggests 48, but it specifically said use our model to predict. So our model predicts on day 26.8. On day 26, I'll go on day 26.8, sometime towards the end of the 26th day, give or take. I know day 26.8 sounds weird, but we figured it out. According to your model, on what day did the corn germinate? Did it emerge from the ground? If it emerges from the ground, what's its height? Because it can have, since it's starting in the ground, we could think of that as a negative height. Okay, so what do we really want to find? We want to find that. What do we call that point on any graph? X-intercept, except on your graphing calculator, what do they call it? Oh, ironically, we're finding the root of corn. I waited all year for that joke. Boy, tough audience. So in theory, after planting, you'd think it would come up after about a week on day 7. Okay. Sorry? You said not found. So what that may have happened, did you move your window around? Can you look at your graph? Can you go Shift F3 and see if you have exactly the same numbers as us? Shift F3, do you have the same numbers as me? No. What happened then is you might have hit an arrow key and accidentally, if you go arrow while you're looking at the graph, it'll slide the screen sideways or up or down or left. You might have then slid sideways so far over that the root was no longer on screen. And it's saying, I can't find it because it's not on the screen. Okay? So go back and that's why, by the way, it's a good habit to write your view windows down. So if you accidentally do that, you can fix it. Okay. One more time, which of the following scatter plots would best fit a logarithmic equation? First one? No, I think that's linear, right? Second one? Oh boy, it's sort of doing that like a log, but sort of. So I'm going to say maybe. Third one? Yeah, I don't think it's that one. That's an exponential. Justin, what does every single exponential graph look like? Yeah, you know what? I think this is exponential, isn't it? In fact, I also think this one here is exponential. This is number 3 is a growth. I think number 2 is a decay. I think this is a logarithm. That's coming closer to that pattern, right? I mean, it can look like this as well, and this sort of looks like that, but I don't think so quite like that. Don't think so. Again, Connor, we would need more data. We don't have more data because I'm not going to have you type in 90 points. I think there's one question where you end up typing about 20 in the textbook in the homework, and I didn't mind that one because it was interesting, and that did give you pretty good data. What's your homework? So on page 494, number 3, for ABC. Number 5, careful, think very carefully which should be on the x-axis, pressure or altitude, 6, 8, and 9. And the take-home quiz. You'll finish this in class pretty easy.